Have you ever heard a sentence so twisted that it could prove 2 plus 2 equals 5? Not metaphorically, literally. Tonight, we're diving into a logic paradox so strange, it can make any falsehood seem true. Curry's paradox. It's not a trick, it's not a riddle, it's a real logical structure. And it might be the most underappreciated mind bender in all of philosophy. So put on your headphones, dim the lights, and follow the quiet unraveling of logic itself.
Let's start with a seemingly simple sentence. If this sentence is true, then 2 plus 2 equals 5. At first, you might laugh. You might think, well, clearly 2 plus 2 doesn't equal 5, so the sentence must be false. But wait, that's not how conditionals work in logic. In formal logic, a conditional statement, if A, then B, is considered true in every case except when A is true and B is false. So let's unpack this. Let's call the sentence S. So, S equals, if S is true, then 2 plus 2 equals 5. Now here's the twist. If S is true, then the consequence is that 2 plus 2 equals 5, which is false. So that can't be. But if S is false, then the statement, if S is true, then 2 plus 2 equals 5 doesn't apply because the condition never arises. And in formal logic, that means the whole sentence is still considered true. Wait, what? Yeah, if the condition in the if clause never happens, the statement is valid by default. So we get stuck.
Curry's paradox is what happens when self-reference meets conditional logic. It's named after Haskell Curry, a logician who showed that any sentence structured like this, if this sentence is true, then X, can be used to prove X. And that's terrifying. Because if you accept that the sentence is true, and the sentence says, if I'm true, then the moon is made of cheese, well, you just proved the moon is cheese. Or that unicorns exist, or that 2 plus 2 equals 5. It's not a joke. It's a breakdown in how our logical systems handle self-reference combined with implication. And it gets worse. Curry's paradox doesn't require any contradictions to work. That's what separates it from the liar paradox or Russell's paradox. It slips through logic's defenses without contradiction. You might wonder, so what? It's just a clever sentence. But here's the real impact. If your system of logic allows unrestricted self-reference and basic implication rules, you can derive anything. Your system becomes explosive. You can prove any statement, true or false. In math and computer science, this is devastating. It means your foundational system, like the set of axioms that build up arithmetic or programming logic, is no longer trustworthy. It's why mathematicians had to carefully restrict self-reference when formalizing systems like Zermelo-Fraenkel set theory. You have to avoid unrestricted abstraction, or you get Curry's paradox hiding in the walls. Here's where many get tripped up. They assume the sentence must be false, but in formal logic, a conditional with a false antecedent can still be true. They confuse Curry's paradox with the liar paradox. The liar says, this sentence is false, and loops endlessly. Curry says, if I'm true, then X, and leads directly to explosion. No loop needed. That's why we have safeguards. Type systems, restricted grammars, limited comprehension. Not because logic is weak, but because it's powerful enough to break itself if left unchecked. So what do we do with Curry's paradox? We study it. We fear it a little. And we remember it. Because it reminds us, even truth has to be handled with care. Words, structure, implication, they don't just describe logic, they are logic.
And sometimes logic can twist in on itself and hand you the keys to any door, even the ones that shouldn't open. Here's something to dream about. What would happen if an AI trained on billions of logical statements started building Curry-style constructs without realizing it? Could it start proving anything and believing it? Sleep well.